Here we go with some more related rates today. So this time we're going to have much more fun pictures to try to draw. So we've got Sue standing on a dock. So like I said, I'm one of the best picture persons in the world. Not. So here's Sue. She's pulling in a boat. She's pulling a boat into the dock by means of a rope tied to the string of the boat. So here's my boat. Here's this. She's pulling it in. If the ring is 2 foot above the water level, so this is 2 foot, and her hands are 7 foot above the water level, and she's pulling the rope in at a uniform rate of 2 foot per second, we're going to find the speed which the boat is approaching the dock when it's 12 foot from the dock. Wow, a lot of things taking place here. Well, the first thing I'm going to do is I'm going to take out part of my picture. So as I can see right here, I have a right triangle. I'm going to recreate that right triangle. And I now know that this side is 5. I'm going to use X, Y, and Z again, as I've done in prior problems. Well, what do I know? What am I given? I'm going to reread this. I am given that she is pulling in the rope at a uniform rate of 2 foot per second. Well, that's this right here. So that's side Z. So side Z is changing with respect to time at 2 foot per second. Now we have to keep in mind that that is actually going to be a negative 2 foot per second because the rope is getting smaller and smaller. It's getting pulled in. It's going to the left. The next thing I know is just really what y is equal to. And I've already marked that in the picture. So I'm going to find the speed at which the boat is approaching. So that would be the change in the x here. So I'm going to find dx over dt when the boat is 12 foot from the dock. So when x is equal to 12. The formula I need is Pythagorean theorem. X squared plus y squared equals z squared. Now I was given the y part, so I will go ahead and plug that in right now because it will make it easier when I go to take the derivative. So I have the derivative of x squared is 2x dx over dt. The derivative of 5 squared is just 0 because the derivative of a constant is 0. And I have 2z dz over dt. I'm supposed to find dx over dt. I'll plug in some known values right now. This is still 2. The x value is something that I still need to figure out. No, I don't. That's what they told me. It's 12 down here. It's 12. I'm supposed to find it when x is 12. I know this is a 5, 12, 13 right triangle, so I know that z is 13. I have 2 out here in front. And I'm going to find dx over dt. The last bit of piece of information I need is dz over dt, which is negative 2. Well, this number right here, 13 times 2 times negative 2, happens to be, 26 times 2, negative 52. And over here I have 24. Divide by 24 on both sides, I get dx over dt is equal to negative 52 over 24. That does reduce down to be negative 13 over 6. And my label would be feet per second.